Hi everyone, welcome back to Learn with Aksha. I'm Aksha Rubin. So in today's video, we're gonna learn series parallel reduction technique. To begin with, let's start with series connection. So in the diagram, you can see there's a battery and there's a current I flowing from the battery. The same current I flows through the resistance R1 and R2. So if the same current flows through resistance R1 and R2, both the elements, then they're connected in series. If the same current flows through both the resistance, they are connected in series. So in such a series connection, how do you find the equivalent resistance? To find the equivalent resistance, you simply have to add both the resistance R1 and R2. You just have to do R1 plus R2. Simply add and you'll get the equivalent resistance. Next is parallel connection. So look at circuit 1, there's a battery and there's a current I flowing from the battery. This current divides between both the resistor, resistance R1 and R2. In resistance R1 we have a current I1 and in resistance R2 we have a current I2. The current I divides between both the resistor, hence they're connected in parallel. If the current divides between the resistance, then they're connected in parallel. So how do you find the equivalent resistance if the resistance are connected in parallel? You simply have to do the product of the resistance divided by the sum of resistance. So in this case, it will be the product. So R1 into R2 divided by the sum R1 plus R2. That's written here. R1 into R2 divided by R1 plus R2. And you'll get the equivalent resistance as you can see in circuit 2. Next important theory is current divider rule. So what is current divider rule is when you have lots of branches, if you have to find the current through one of the branch, that's when you use the current divider rule. So you can see here there are two branches. You can see the current I1 flows here, the current I2. That's a total current of IP flowing from the battery. It divides between both. And what if you have to find the current through the resistance R1, the current I1? If you have to find current I1, you use the current divider rule to find the current through the first branch, or the R1 through the R1 resistance. So the rule is basically the current, to find the current in this branch, it's the total current flowing through into the resistance of the other branch divided by the total resistance or sum of resistance. So in this case, the current is I1 equal to the total current, that is IP, into resistance of the other branch. So other branch is this one, resistance is R2 divided by sum of resistance, so R1 plus R2. That's written here, I1 equal to IR2 divided by R1 plus R2. And if you have to find the resistance, if you have to find the current in the this branch across resistance R2, I2, then it would be the same, the total current and then resistance of other branch. So for this, the resistance of other branch would be this. So resistance of this branch is R1 divided by the sum of resistance R1 into R1 plus R2 sum. Next is the main topic, series parallel reduction. So while doing series parallel reduction, you gotta start with the source. So from source, you have to name the current. You have to mark the current in all the branches and you have to name them. And then from the end, the dead end, you have to start reduce the circuit, reduce the resistance, and by that you gotta reduce the circuit. So first from the dead end, you have to see if the last two resistance are in parallel or series by finding if the same current flows through both the elements or does the current divides between the element. And then using the equivalent resistance, you have got to find the equivalent resistance and then replace with the equivalent resistance, replace those two resistance with the equivalent resistance. Then you have to repeat the same step until the last resistor, so the last equivalent resistance, and then there's only one resistance. So now you can find the current using the Ohm's law, and then you have to mark the current in all the branches by going from reverse. You have to proceed backwards, marking all the current till you reach the original circuit. You'll understand this better when we do some problems. So here we have a problem. Find the branch current using series parallel reduction technique. So this is the circuit. As you can see, there's a source which is 24 kilo volt, and here you have, I think, 6 kilo ohm resistor, 4 kilo ohm resistor, 3 kilo ohm resistor, 4 kilo ohm resistor again, 12 kilo ohm resistor, and 8 kilo ohm resistor. So this is the circuit, and we are gonna find the current in all of the branches. So current across this, and the 12 kilo ohm resistor, 3 kilo ohm resistor. So we have to find the current. So like I said, the first step is marking the current through all the branches and naming them. So here's it's done. So from source, as you go, first we have marked this current from the source as I1, and then when you reach here, the current divides between both the resistance. So I2 and then I3, and then I3 flows through the 4 kilo ohm resistor, and when it reaches here, it splits into 3, so it gets divided as I4, I5, and I6. And then the I6 current flows through the 4 kilo ohm resistance and then to the 8 kilo ohm resistor. Now we have marked the current in all the branches from the source. Next step is to reduce two resistance at a time from the dead end. So in this case, this is the dead end, and there are two resistance here, which is the 4 kilo ohm resistor and the 8 kilo ohm resistor. So we have to find if they're connected in series or parallel. To find that, you see the nature of current. So here the I6 current flows through both. I6 flows through the 4 kilo ohm and I6 flows through the 8 kilo ohm. So they are connected in series, since the same current flows through both the resistor. So how do you find the equivalent resistance? You just have to add both the resistance. So it will be 8 plus 4, which is 12. So the equivalent resistance is 12. Now next step is to replace that with the 12 resistance. So instead of these two, the equivalent resistance is 12. So we add the 12 kilo ohm resistor instead of those. Now you have to mark the current again from the source in all the branches. So I1 current flows here, it splits into I2 and I3, and then I3 flows through the 4 kilo ohm resistor. When it comes here, it splits into 3, I4, I5, and I6. Next, you have to do the next two resistance. So the remaining two will be the 12 kilo ohm resistor and the 12 kilo ohm resistor. Now we have to find if they are in series or parallel. So the current through this 12 kilo ohm resistor is I5, and the current flowing through this 12 kilo ohm resistor is I6. So the current in both divides. The current is getting divided between both the resistance, hence we can conclude that they are in parallel. If they are in parallel, you know the formula for equivalent resistance, which is the product of both the resistance divided by sum of resistance. So the product of this will be 12 into 12 divided by the sum, 12 plus 12. And when you do that, you'll get 6 kilo ohm as the answer. So next step, obviously, substituting the, putting the 6 kilo ohm here instead of both the 12. Yeah, basically like this. You put the 6 kilo ohm instead of those two, and then you have to mark the branch current again. So I1 flows, it gets divided as I2, I3, and then I3 flows, it gets divided into I4 and I5. Now the last two resistance again. So in this case, from here, when you see the last two, it will be these two, I5 and I4, the 6 kilo ohm resistor and the 3 kilo ohm resistor. Yes, so you have to find if they are parallel or series. So here you can see the current I3 gets divided as I4 and I5. So there's division of current. In that case, they are parallel. So if they're parallel, you use the law. So it is the product of both the resistance divided by the sum. It is 6 into 3 divided by 6 plus 3. You'll get the answer 2 kilo ohm. Then you put the 2 kilo ohm instead of these two. You have to replace those two with the 2 kilo ohm equivalent resistance, and then mark the current again from the source. So from the source we have the current I1 flowing through, and then it gets divided to I2 and I3, and then I3 flows. So next you have to reduce last two. Again, here if you see the last two, these two will be the last two. So 4 kilo ohms and 2 kilo ohms. So we have to reduce them. Yes, 4 and 2 kilo ohm. We are going to reduce them into the equivalent resistance. For that, we have to find if they're connected in series or parallel. So we see the nature of current. The current I3 flows through the 4 kilo ohm resistor, and the same current I3 flows to the 2 kilo ohm resistor, which means they're connected in series. So if they're connected in series, you simply have to add both the resistance. So it will be 2 plus 4, which is 6. So the equivalent resistance of these two is 6. In that case, you have to replace these two resistance with a 6 kilo ohm resistance. And here you go. Those two resistance are replaced by a 6 kilo ohm resistor. Now you have to mark the current from beginning again. So the current I1 flows through. The I1 current splits into I2 and I3. Yep. Now we have to reduce the resistance, both the resistance, to find the equivalent resistance, to find the nature of the current. You see the current gets divided. The current I1 gets here, it splits into I2 and I3. So the current I2 flows through this resistance, and the current I3 flows here. So they are in parallel. If they are in parallel, you have to find the product of both the resistance divided by their sum. Product is 6 into 6 divided by their sum, 6 plus 6, which is 3 kilo ohms. Now we got the final circuit, the last resistance, the last equivalent resistance. So we replace those 6 ohm resistance with the 3 kilo ohm equivalent resistance. Now it's very easy to find the current because you just have one resistance and you know the voltage from the battery. So you can use the Ohm's law to find I1. I1 is equal to V by our equivalent resistance, which is 24 kilovolt. So 24,000 divided by 3 kilo ohms, so 3,000 equal to 8 ampere. So you know the current I1 is equal to 8 ampere. Now to mark the current in all the branches, you know the total current is 8 ampere. Now you have to mark the current in each of the branches in the beginning circuit. So we go in reverse to the previous circuit. So the previous circuit is this one. There's 6 kilo ohm and 6 kilo ohm. So here the current I1, which is 8 ampere current, gets splits into I2 and I3. Here's where you use the current divider theorem. So to find the current in the branch I2 branch, you use the current divider theorem, which is the total current, that's 8 ampere, into the resistance of the other branch. So the other branch is this branch and its resistance is 6 kilo ohm divided by the sum of resistance. So 6 plus 6. That will give you an answer 4 ampere. So the current flowing through I2 is 4 ampere. The total current is 8 ampere. From that itself you can find that the I3 current will be 8 ampere, or otherwise you can use the same current divider theorem for this branch also. So to find the current in the I3, you can use the total current 8 ampere into the resistance of other branch 6, and then the sum of both the resistance divided by the sum of both resistance, and then you get the answer 4 ampere. Next you go to the previous circuit of that is this circuit. So in this circuit you can see, you know that the current I2 is 4 ampere. From the previous we know that it's 4 ampere and I3 is 4 ampere, so that's what they've put here. I1 8 ampere flows here. It gets splits into I2, which is 4 ampere, and I3, which is 4 ampere. So the I3 current flows through both the resistance, so you don't have to find the current through that. It's in series, so you don't have to find the current. Next previous circuit is this circuit. So in here you know that I1 is 8 ampere. It gets splits into I2, which is 4 ampere, and I3, which is 4 ampere. The I3 current gets split here again as I4 and I5. So you have to find the current through I4. So if you're finding to I4, then the total current, which is 4 ampere here for these two branches you're finding. So here the current that is flowing is 4 ampere. So 4 ampere current gets splitted. So 4 ampere into the resistance of other branch. So if you're finding for I4, the resistance of the other branch will be 6 kilo ohms. So into 6 divided by the sum. So 3 plus 6. That will give you an answer 2.67 ampere. So the total the I4 value is 2.67. From that you can find the current through I5 by just subtracting that from the total current here. So it will be 4 ampere minus 2.67 ampere. It will give you the answer for I5, or you can use the current divider theorem again with I5. So that would be I5 is equal to the current flowing there, it's 4 ampere, and the resistance of other branch. So this branch, the resistance is 3 kilo ohm. Then this divided by the sum of resistance, that is 3 kilo ohm plus 6 kilo ohm. That will give you the answer 1.33 ampere. Now we gotta go to the next previous circuit. That was the circuit. So here again I1 you know, I2, I3 you know, and then here it gets split into I4, I5 and I6. Again you need to find the value of I6. So to find the value of I6, it is I total, which is here you found the I total. So that is this value 1.33. So I total into the resistance of the other branch. So if you have to find the resistance here if you have to find I5, the current I5 in previous circuit, you see there's the current I5 total, I5 total, which is an equivalent resistance for these two. So we are gonna find I5 first. So I5 will be the I total. So the total current here was 1.33 into the resistance of the other branch, which is 12, divided by the sum of resistance, and that will give you the answer 0.67 ampere. And then to find I6, again the total total current was 1.33 ampere, and the resistance of other branch, which is this branch, and the resistance is 12 kilo ohms, and just divided by the sum of resistance, that will give you 0.67 again. So now we have marked the current for all the branches. This is the original circuit. So here we have the I6 value. We know it was 0.67. So the I6 flows through both 4 and 8 kilo ohm resistors. So now we have marked the current in all the branches. As you can see, I1 we know it's 8 ampere, I2 we know 4 ampere, I3 we know 4 ampere, and then I4 is 2.67 0.67 ampere, and then I5 is 0.67 ampere, and I6 is 0.67 ampere. Likewise, you will get the current for each branch in the original to the original circuit diagram. You gotta do it in reverse until you reach the original diagram by substituting the I values. Use the current divider theorem wherever it's necessary. So that's all. That's how you do series parallel reduction. I hope you understood. So thank you for watching, and see you all in my another video. Bye bye. Bitch, I'm the goat, feel like I walk on water. I'm talking your bitch, till he like I'm a toilet. Walk with the Glock on the fuck or a bar. Throw my boy out with his head, we play soccer.